Hey, and we're back. We are going to do the second part of molarity calculations, and that is where we're going to be converting from grams and volume into molarity. And this is actually all stuff you already know how to do. So we're not doing anything really different. Now, what we did last time is we actually went from moles divided by the volume to get our molarity. The only difference here is I'm starting with grams. Now you know how to go from grams to moles. We did that last week. You can go back to those videos in the worksheet that you've done to go through and double check those. But let's just go ahead and work through. And I'm just working two problems because they're actually really not anything different than what we did last time. We just add one step. So let's go ahead and start on number 7. So once again, I know I'm looking for molarity. And molarity is going to be moles over liters. Well, first of all, I don't have moles. If we look, I do have a liter value. So, easy enough. I have grams. The only thing you can do with grams is convert to moles. We know that. We did that. So, you write down what you're given. And it's sodium hydroxide, so you have to go ahead and convert that into formula. Watch your charges. Make sure you get stable compounds. +1, -1, we're good to go. Take what you're given, you put it over 1. That begins to become very important. Now, I have grams, but I need to get moles because moles have to go on top. The thing you're looking for always goes up top. And that's moles of NaOH. Always keep our formulas with it. Well, I need to get rid of grams. What you're trying to get rid of always goes on the bottom. And you're going to see now they cross cancel. I saw a few people turn in work to where they did not have any units and they actually were putting numbers in the wrong spots because of that. That's why I say, okay, make sure these cross cancel. Now the mole value, whenever you convert into or out of moles, that mole value is always 1. That gram value, remember, 1 mole of a substance equals the molecular mass of that substance. So I already did the work for you, but going through, I know I've got NaOH, I did the breakdown, went through and I filled out the chart. Calculator value is 40.01 when I add all that together. I adjust for where it cuts, tens position, so 40.0 is my molecular mass for sodium hydroxide. So I'm just going to put that on the bottom. Okay, so we're good to go on that. Now, if I solve for this, that's going to get me my mole value. So it's actually, we're going to do 2 steps here. This one is basically what we did last week. So 98 times 1, do that again, divided by the 40.0. And that's going to set up at 2.45. Let's double check that number. 98 divided by, 40.0, 2.45. Okay. So and that's moles NaOH. Now, notice I am not adjusting for sig digs yet because I'm not done with the problem. We only adjust for sig digs at the very end. So now I have to bring in the other thing because I want molarity is moles divided by liters. So now I bring in my liter value. Okay, that's what's going to come down right there. So I'm going to bring in 2.2 liters. Now, at that point, I have my moles over my liters, which is what molarity equals. So I'm just going to go ahead and plug in, do the math. Well, 2.45s are in the calculator. So now I divide by what's on the bottom, the 2.2. And that's going to give me this answer. And once again, about 5 digits, 6 digits, 1, 2, 3, 4, 5. What the heck, we'll throw in another one. Okay. So now we've got to adjust for sig digs. If we look at the 2.45, the 98, the 40.0, ideally you're going to not worry about this answer because that's not an adjusted answer. That's a calculator value. We're going to go back to the initial values. So in this one, there's 2. 40.0, we've measured out that level of precision, so that's a real 0. And down here, given values, there's 2 as well. That means my answer is going to get 2 sig digs. 1, 2, drop my line. I look 1 spot over. It's not greater than 5, so it can't round. That means my final answer becomes 1.1. But it's 1.1 what? Well, it's 1.1 molarity of NaOH. And that is the problem. Does that first part, that's what we did last week, straight mole conversion. This is what we learned at the top portion, molarity is moles divided by liters. So we've just combined the two. So it's really nothing earth-shaking. Okay, let's do number 9 as a review. 6 and 8 are going to be following the same process. Those are the ones you get to do. Put molarity as moles over liters because that's kind of a reminder for me. I've got 45 grams of ammonia. Now, ammonia is not one you've seen before, okay? But things like that, you can always look it up. Ammonia, I'll tell you right now, is NH3. It's related to ammonium, but this is ammonia. Okay, so it's NH3. Those are the same thing. That's its formula. We put it over 1. Now, I'm looking for molarity. Molarity is moles over liters, so I'm looking for moles above. Okay, it's moles of what? Moles of NH3. I have grams of NH3, but I've got to get rid of it. So that means grams of NH3 are going to go on the bottom. So if we look now, grams converted to moles, that mole value is always going to be a 1. So now we get the molecular mass, and once again, I worked it out. There's our NH3, basically plugged in number of atoms. Masses did the work, and it becomes 17.0. And you've got these in classrooms, so you can easily pull those off. So at this point, grams of NH3 are gone. I'm in moles of NH3, which is where we're looking. So I'm just going to go 45 times 1 divided by 17.0. And that's going to give me 2.6471. Oops. Let's see if I can write it a little bit clearer for you guys. 2.6471. Okay. And that's moles NH3. But once again, I'm looking for molarity. So that means I've got to take my mole value and I have to divide it by whatever my liter value is. In this case, it told me 0.75 liters. Now, here's one trick. Okay. I wrote a number down. I took it to 5 digits. Now, I did that just so I actually have some number here. But I'm going to leave this number in the calculator because otherwise this is a rounded value of this one. And when I'm doing math work, it actually could impact our answer. So we're never going to clear that calculator value until we're completely done with the problem. So now that's the entire thing. I just don't want you writing out all of that. That's just not worth it. Okay, so now we're going to take this and we're going to divide by the 0.75. So divide 0.75. And that's going to give me that answer. 3.5294. 1. Okay, I want to double check my values. So I'm going to go 45 times 1, divide what's on the bottom. There's my 2.64, blah, blah, blah. Now I'm going to divide by the 0.75 and 3.52941. Notice it kept going. I don't need to go that far out. So now I adjust for sig digs. Well, in the 45, there's 2 sig digs. 17.0, we measured that level of precision. That means that 0 is real. The 1 mole, remember, that's always infinite. The 1 decimole is an infinite number of sig digs. That's calculated. I don't care about that. And here's 2 sig digs. So my answer is limited to the least number, which is going to be 2. 1, 2. Draw my line. We look 1 spot over. Can it round? Nope. So that means my answer becomes 3.5. 3.5 what? Well, I'm looking for molarity. So molar NH3. And that's it. That's all you do on that type of problem. This is converting into molarity. Okay, now so I can do it from moles and liters, or I can go actually from grams and liters into molarity. That's that type. And I'll cover the next type in the next video sequence, but hopefully that makes sense. And go ahead and do the even problems on this worksheet. You can do the even problems on all the worksheet, and then we'll have the ultimate Google form. You'll plug in your even answers, and we'll see if you're right. I will post this online, so you can actually compare against your odd answers to make sure you're doing it right. Thank you. Have fun. Have a day.